This is the Innova Engineering introduction video. In this video, I'm going to go over the basics of setting up and running engineering. So that includes installation and uninstallation of engineering, and the important parts of the engineering installation folder, as well as how to add your license and apply a patch. I'll go over how engineering project files work. I'll give an overview of the engineering interface, and then I will run through the general workflow that you would follow for a torque and drag or hydraulics calculation. So we'll start with installation and uninstallation. I already have Innova Engineering installed, so I'm going to cover uninstallation first. To uninstall Innova Engineering, you need to access your control panel. In Windows 10, you can do this by opening up your Start menu, scrolling down to Windows System, and then selecting Control Panel. Windows can display your control panel in a couple of different ways. If it looks like this, you want to click on Uninstall a program here. If it looks like this or like this, then you want to click on Programs and Features. This will bring up the window that lets you uninstall Innova Engineering. So you just want to find Innova Engineering in the list and then click on Uninstall up here. Innova Engineering will ask are you sure? Just hit yes, and then the installer should do the rest. And then you can just close your Programs and Features window. To install Innova Engineering, you're going to need the installer exe, which looks like this. It's going to have the name Innova Engineering and then the version number and then .exe. But when you buy a license from Innova, we might send you this in the download link, but if you don't have it, you can always get it from our website. To get the installer from our website, you want to go to our homepage, www.innova-drilling.com, and then you want to click on the free trial button at the top of the page. This will take you to a form that you need to fill in, but once you've completed it, to click on Submit. This will take you to our download page, and you can click on this link here to download the Innova Engineering installer, and you can also click here to read the release notes for the latest version. Once you've downloaded the installer, just double click on it to run it. The program will ask you where you want to install engineering. I'm just going to leave it as the default in program files. You also need to agree to the license terms and conditions before you can install engineering. You can read about them by clicking on this link just here. You will also need administrator privileges in order to install engineering. So if you're in an office environment with an IT admin, you might not have access to admin privileges, so you'll have to get your IT administrator to install engineering for you. Just click on the install button and engineering should install. It only takes about a minute. The installer may also ask you to install a couple of prerequisite files. These are all just drivers created by Microsoft that the program needs to run. So if it asks you, just say yes, and then the installer should continue. Once you get to this screen saying Innova Engineering has successfully installed, you can just click on Finish, and you should now see a shortcut for Innova Engineering on your desktop, and also a shortcut in your Start menu. So now that I've installed Innova Engineering, I can go and have a look at the install directory. I installed engineering at the default location, so it's just in my local disk, Program Files x86, Innova Drilling and Intervention, Innova Engineering, and this will bring me to the install folder. The most important part of the install folder is the Innova Engineering application itself. This is what runs when you select the shortcut either in your Start menu or on your desktop. Occasionally, Innova will discover a bug in engineering that we want to fix quickly. So instead of waiting to release a new installer, we will release what we call a patched exe. A patched exe looks something like this. It'll just be called innovaengineering.exe as opposed to our installer, which looks like this. It'll say Innova Engineering and then the version and then .exe. If we send you a patched exe, all you have to do to apply the patch is to just copy the patched exe, go to your Innova Engineering install directory and paste it in overwriting the old exe. The second most important file that goes into the Innova Engineering install directory will be your license file. When you first install Innova Engineering, it comes with a 2-day trial license, but after that expires, you will see this window. This window contains your computer code. When you buy a license from Innova, we'll ask you to send us this computer code, because this is what allows us to lock the license to your computer. Innova will then send you back a license file which looks like this. It'll just be called eng_license.txt, and this is just a simple text file that contains your licensing code. To activate your license, you just want to copy your license file, go into your Innova Engineering install directory, and just paste it into the folder. Once you've placed your license file into the Innova Engineering install directory, you should now be able to run engineering with all of the features on your license. There are two more important parts of the engineering install directory, and those are the example projects and manuals folders. The example projects folder contains a number of completed engineering example projects. These can be used to practice on and also to explore some of the features of Innova Engineering. The manuals folder, apart from containing the full Innova Engineering manual, also contains a number of guides for most of the features in Innova Engineering. So if you ever get stuck, this is an excellent resource to come and get help. So now that we've covered the setup of Innova Engineering, we can look at the program itself. So I'm just going to run engineering by double-clicking on my shortcut on my desktop. This will open up engineering in a blank project. So the engineering interface is split into three main sections. You've got your project name and description box in the middle. You've got your input tabs down towards the bottom, and then up to the top, you've got your menus. We've also got a toolbar, but all the items in this toolbar are just shortcuts to items in the menus, so I'm not going to cover them. If you need to know what they do, you can just hover over them and they'll tell you which item in the menus they link to. I'm going to run through a demonstration of the general workflow for doing a hydraulics or torque and drag calculation, which will cover most of these tabs and most of the menus up here. But before that, I'd like to cover some of the more important menus, starting with the help menu. The first item in the help menu is also called help, and this will open up the engineering manual. The engineering manual is an excellent reference document for just about every feature that we have in engineering. So if you forget what an option in a menu does or an input field in a tab, the best place to look first is the engineering manual. The next option in the help is the about option. So this will just tell you what version of Innova Engineering that you're running. And we've got the open documentation folder. So this opens the manuals folder that I showed you earlier in the Innova Engineering install directory. So if, for example, you were doing a torque and drag calculation and you needed some extra help, you can open up this folder via the help menu, and then you can open up the torque and drag quick start guide, which will guide you through the process. Next, we have the Open Install Folder option. This just opens up the Innova Engineering install directory. We have the Open Project Folder option. This opens up the folder that contains the project that you currently have open in engineering. Then we have the Check for Update option. If you click on this, it will open up the download page on the Innova Drilling website. So this is another way to quickly get the Innova Engineering installer. Next, we have the tutorial videos option. So clicking on this will open up the Innova Drilling and Intervention YouTube channel. So the Innova Drilling and Intervention YouTube channel is another resource that contains a number of shorter tutorial clips which can guide you through specific features in engineering. If you click on playlists at the top, we have some Innova Engineering specific playlists as well. Then we have the license info option. So clicking on the license info option will bring up the license details window. In this window, you can see your license key. You can also see your computer code, and you can see the features that have been enabled in your license. And then finally, down at the bottom, you can see when your license is going to expire. You also have this deactivate license button just here. So if you need to deactivate your license on your computer, because say you're transferring your license over to a different computer, we will ask you to click on this button here, which will deactivate your license and also generate a deactivation code. We then ask that you send this deactivation code to us, either to the support account or the sales account, and this will confirm to us that you've deactivated the license on this computer. Lastly, we have the screen info option. This just contains some information on your screen, such as your resolution. This is mainly used for debugging issues. So if you do encounter a visual bug, sometimes we'll ask you to look up your screen info and read off the details for us. The next menu that I want to go over is the file menu. So this has the standard options you would expect in a file menu: new, open, save, and save as. New will just create a new blank Innova Engineering project. Open, you can use to open an existing project, and then save as and save or save the project that you currently have open. So unlike RoleSeeker, which stores all of its data in a database, when you save an engineering project, it saves it as an individual .ing file. So for example, we've got a .ing file here, and these files work a lot like Word documents or Excel spreadsheets. You can copy and paste them and they'll work just fine, and you can double click on them to open them. Each engineering project file can only store one set of inputs, so one BHA, one of each survey type, and one set of input parameters. And if you want to change any of these inputs without overwriting any of your previous work, then you need to save the project as a new project. So for example, if you were doing hydraulics and torque and drag calculations for a whole well, then each BHA or each whole section would be its own project file. Likewise, if you were varying your input parameters and you wanted to compare the results, then you would have to save each different configuration of your parameters as a separate project file. This means you can end up with quite a lot of engineering project files, so good file management is very important. So for example, I've got a well here that I'm modeling, and I've split up my BHA runs into folders. So I've got one for my 17.5-inch run, one for my 12.25-inch, and one for my 8.5-inch run. And then inside my 12.25-inch run, I've also varied my mud type and my drill pipe that I've been using, and I've saved a different project file for each configuration. The other options in the file menu I'm going to cover in more detail in other videos, but I'll just briefly go over them now. So print reports brings up the reports manager, which lets you print out reports for your outputs after you've run a calculation. Print BHA will let you print off the BHA that you've set up in your drill string tab. Import survey allows you to import surveys into your surveys tab. And then export BHA and import BHA lets you import and export drill strings out of the drill string tab. and then finally exit or shut down Innova Engineering. Next, I'm going to go over the units menu. So this is where you set up the units of measurement for all of your inputs and outputs in the project. Obviously, it's very important to get your units correct, otherwise your outputs aren't going to make any sense. So you can go through each of the different units individually if you want to and pick the one you want. Or alternatively, you can go down to the three options down here and you can choose one of the preset unit sets that we have set up in engineering. So when you pick one of these, all it does is it automatically picks all of your measurements up here so that they match with the unit set. So for example, if I pick the API unit set, this will set my mud weight to ppg, my length to feet, and my weight to thousands of pounds, and so on and so forth. Unlike in WellSeeker, when you change a unit in engineering, it does not convert the values of any inputs that you've already put in. So for example, my length units are in feet at the moment. If I change these to meters, you can see that the unit at the top of the column has changed to meters, but the actual values themselves have not changed. The unit sets that you've picked are saved in each individual project file. So now I'm going to give a demonstration of the general workflow that you would follow while doing a hydraulics or torque and drag calculation. And at the same time, I'm going to give a pretty high-level overview of the main tabs and also some of the other menus at the top up here. So normally you would start by going to File and New to create a new blank project, but I'm going to leave this example project open so that you can see what the tabs look like when they're populated with data. So after creating your project, you would give it a name and a description, and then the first thing you would do is go up to the Units menu and select your units. You can either pick them individually or you can pick a unit set. In this case, we're working with the SI unit set. Once I've picked my units, I can start filling in my tabs, starting with the drill string, weld geometry, and fluids tab. So the left-hand section of this tab is where we construct our drill string. To build the drill string, you just want to enter in a line into the table for each component. So you would start with your bit and work through your BHA until you got up to your drill collars, your heavyweights, and then finally your drill pipe, which goes back up to surface. To enter in a new component, you just go down to the empty line at the bottom, select your component type from your drop-down box. So I'll just pick some more drill pipe, and then you can enter the information for your component into the table. Each component that you enter into the table also has some component details in this bottom section down here. The component details that you can enter depend on the component type that you picked in the component column, and this is where you can enter some extra information for that component depending on the type that you've picked. So for example, in a bit type component, in the component details, this is where you would enter the TFA information for your bit. Once you've finished building your drill string, you then move over to this section here, which is the weld geometry section. In the weld geometry section, you describe the state of the hole at the time that you run your calculation. So in this case, we're simulating the 12 1/4 inch section. So I've got a 12 1/4 inch open hole that is running down to the bottom of the 12 1/4 inch section, and then above it, I've got the casing string for the section above. So in this case, we're drilling on land, so we've just got casing and open hole, but we also have options for, say, putting in a visor if you were drilling offshore, for example. Once you've filled in your raw geometry, you then move down to the fluid properties section in the bottom right. So this is where you fill in the information for the mud that you're drilling in. You can fill in your mud manually by just entering in the mud weight, PV, YP, your N and K readings, and your mud rheology reading. or alternatively, you can pick out a preset mud from our fluid library. So when you install engineering, the fluid library comes populated with a few standard muds, but if you want to, you can also add your own mud and save it in the library. In the bottom left of the fluid properties section, we've got the cuttings details. This is used for calculating the dirty ECD in the hydraulics calculation. You can leave these values as their defaults, or you can edit them here. And then finally in the bottom right, we've got the additional fluids section. So this section is turned off by default, but if you want to, you can enable it, and then you can put in information for stuff like a PIL or LCM, and this will modify your mud weight depending on the volume and the density that you've entered. So once we've finished with the drill string, well geometry and fluids tab, we can move on to the surveys tab. So the surveys tab is where you set up the well profile using either well plan stations or using real surveys. In engineering, you can store 3 different surveys in one project file. So you can store one set of actual surveys, one well plan, and one set of raw surveys. Raw surveys can't be used in hydraulics or torque and drag calculations. They are used just for survey correction. If you're running a hydraulics or torque and drag calculation, you need to put in some actual surveys or some well-planned survey stations. So you can enter your surveys manually by just typing them into the table. If you have a source of data that is in a table format, such as an Excel spreadsheet, you can just copy and paste them straight into this table in engineering. And the other option is to import them by going to File and Import Survey. In engineering, we have the ability to import surveys from either Excel spreadsheets or delimited text files such as LAS files. Once you've entered in your surveys, you can click on the tortuosity button down here, which will let you add some tortuosity to your surveys if you need to. The purpose of the tortuosity tool is to make sure that you don't have any perfectly straight or perfectly vertical sections of your well, which will give an unrealistic result when you run the hydraulics or the torque and drag calculation. The vertical section area up here just lets you set the azimuth of the vertical section for your section view plot, and then the origin north-south and the origin east-west options let you change the location of your surface location, which will affect the north, south, east, west, and vertical section results in your survey table. The raw survey data and survey correction sections are just for survey correction calculations when you're using raw surveys, so I'm not going to cover them here. Once you've entered in your surveys into the survey table, you can go up to the plots menu and you can view a section view, a plan view, or a 3D view plot, just to check that your well trajectory looks sensible. And then once you're happy with your surveys, you can move on to the next tab, which is the Engineering Parameters tab. On the left-hand side of the Engineering Parameters tab is where you enter in your drilling parameters for your hydraulics and your torque and drag calculations. So it's split into 2 sections. You've got the hydraulic section at the top and the torque and drag section at the bottom. And then in the middle, you just have this survey selection section. This is where you pick from the drop-down box which of the surveys that you entered into the survey tab you want to use. So if you had information entered into both your actual surveys and your well plan surveys, you can pick which one you actually want to run the calculation off of. So in the hydraulics section, you will enter in drilling parameters that are important to the hydraulics calculation, such as your mud flow rate and your tripping in and out speed. And then in the torque and drag section down here, you set drilling parameters that are important to torque and drag, such as your weight on bit and your friction factors. The other 2 tabs are not used in hydraulics or torque and drag calculations, so I'm just going to very briefly describe them. The drilling data tab is a grid where you can enter in real-time drilling parameters that you've recorded, and then you can display this data on your results charts and compare them against the projected results from your hydraulics and torque and drag calculations. I'll go into more detail in the drilling data tab in the reports and charts video. The cementing tab is where you run your cementing calculations, and I will cover this in the cementing video. Now that we've put all of our inputs in, there's just one more thing we need to do before we run the calculation. That's to go up to the options menu up here and check our options. The settings in this menu just modify how the calculation runs when you perform the different calculations in engineering. Some of them affect all of the calculations, while some of them are specific to one or two calculations. So for example, we have some torque and drag model options which just affect how the torque and drag model runs when you run the calculation. And then we've got the same for the hydraulics model options just here. So once we're happy with our options, we're now ready to run the calculation. So to do that, we just go up to the calculate menu up here, and we select hydraulics to run the hydraulics calculation. And if it runs successfully, you should get a little message saying calculation complete. And then we go back up to the calculate menu and do the same for torque and drag. You get some initial results in the engineering parameters tab itself. So you have some hydraulics results in this section, and then you've got some driller's hook load and torque results down in this section. As well as these initial results, now that we've run the calculation, we can go up to the hydraulics results and the torque and drag results menu to have a look at our results tables and our results charts. So for example, I can open up my pump pressure data table. And this will give me results for my standpipe pressure at the different flow rates that I picked. And then I can go up to File up here and export these results out as either an Excel spreadsheet or a text document. Or I can go into my torque and drag results and I can have a look at one of the charts. So I'll just open up my hook loads chart and have a look at the results. So I can use the toolbar items and the menus at the top to customize how my chart looks, and then when I'm happy with it, I can export it by right-clicking and opening my export dialog. This allows me to export my chart as either an image, or I can send it straight to my printer, or I can copy it to the clipboard and then I can paste it into another report. As well as charts, we can generate reports in engineering. So in the hydraulics results and the torque and drag results, we can generate a hydraulic summary or a torque and drag summary. As an example, I'll generate the torque and drag summary. So this creates a PDF report that will contain all of our inputs from our engineering parameters tab, as well as our dual string, wheel geometry and fluids tab. It also generates a summary table of our torque and drag results, along with a hook load chart and a torque chart. And the hydraulic summary will do something similar. So it will have our inputs and then a hydraulic summary, and then it will generate a pump pressure chart and an ECD chart. If we want more customization of the results that go into our reports, we can go back to the File menu and we can go to Print Reports, which will open up the Reports Manager. So in this window, we have a lot more customization options. For example, we can add in a logo. We can also pick if we want to print in PDF or Excel format. And we can also choose exactly which results tables and charts we want to go into our reports. So for example, I will print off a hydraulics report with absolutely everything in it. and this will generate a full report with all of our inputs and all of our results tables and charts. That concludes the Innova Engineering introduction video. We'll now move on to the questions and answers section. After each of these questions, pause the video and see if you can answer the question yourself before you view the answer. Question 1. Where should I place my license file or a patched exe? And the answer is in your install folder. By default, this is in your Program Files x86 folder, Innova Drilling and Intervention, Innova Engineering. Question 2. Where is my engineering data saved? Each engineering project is saved in its own .ing format project file. Question 3. Where can I find the example projects? The answer is the same as question 1. They're in the install folder in the example projects subdirectory. Question 4. Where can I get more information on Innova Engineering? You can get more information from the help file, from the guides in the documentation folder, and from our online tutorial videos. All of these can be accessed via the help menu in engineering. And question 5. How should I report a software issue to Innova? If you run into an issue, you can get more help by contacting Innova at support@innova-drilling.com. That concludes the question and answer section. We will now move on to the practice exercise. If at any point you become stuck with these steps, just refer back to the video for a refresher. First, uninstall and reinstall Innova Engineering. If you've not yet installed Innova Engineering, then install it first, and then uninstall it, and then reinstall it. Next, locate your install folder and the manuals and example projects folders that are inside it. Next, open Innova Engineering, either by running the shortcut on your desktop or in your Start menu. Once you have Engineering open, go to the Help menu and open the Help file. Next, open the License Details window and locate your computer code. And then open the Documentation folder and view a guide. Next, go to the File menu and open up one of the example projects. Once you have that example project open, play around with the units, try changing a few of them, and change the unit set. Go to the Calculate menu and run the hydraulics and torque and drag calculations. After you've run the calculation, go to the hydraulics and the torque and drag results menus and have a look at a few of the results charts that are available. And then finally, go to the File menu and use the Save As function to save the project as a new project file. Thanks for watching. If you have any further questions, you can get in contact with us via our support or our sales accounts, which are displayed on the screen now.